Imagine you are standing on a balcony overlooking the turquoise waters of Miami, holding a cocktail in a $900 million luxury penthouse. You feel a slight vibration under your feet, almost like a heavy truck is passing by, but you are 50 stories in the air. You look at the floor and notice that the expensive Italian marble has a hairline crack running from the window to the kitchen. You set your glass on the counter and watch, in total disbelief, as it slowly begins to slide toward the ocean. This isn't a scene from a disaster movie. This is the waking nightmare for the owners and engineers of one of the most prestigious new towers in Florida, a $900 million monument to wealth and modern design that has discovered a fatal flaw. It is tilting at a rate of 3 inches every single year. In the world of high-rise engineering, 3 inches is a catastrophic movement. It is a slow-motion collapse that the best minds in the business are realizing they cannot stop, and the tower itself simply cannot be saved. To understand why a nearly billion-dollar building is currently acting like a sinking ship, you have to understand the ground it sits on. Miami is a city built on a geological lie. Beneath the palm trees and the neon lights, the ground isn't solid rock. It is porous limestone, which is essentially a giant, wet, calcified sponge. This limestone is full of holes, tunnels, and water-filled cavities. When you build a massive skyscraper in Miami, you aren't just building on land. You are building on a fragile crust floating over the Atlantic Ocean. For decades, developers got away with building smaller structures, but the new era of megaprojects has pushed the limits of what this limestone sponge can handle. When you pack hundreds of millions of pounds of concrete and steel into a single square block, the ground doesn't just hold it. It struggles to survive under the pressure. This specific tower was designed to be a marvel of slenderness. In the luxury real estate market, thin is in. The narrower the building, the more exclusive the views and the higher the price tag. But slenderness comes with a massive engineering tax. A thin building has a much smaller footprint to distribute its weight. It's like the difference between wearing a snowshoe and a high heel. The snowshoe stays on top of the soft ground, while the high heel sinks right in. This $900 million tower is the ultimate high heel, and it is stepping onto the softest part of the Miami coastline. During construction, the engineers followed the standard protocol. They drove piles deep into the ground. But in Miami, deep is a relative term. They hit what they thought was a solid layer of limestone and stopped. They poured the foundation, and the tower began to rise. Everything looked perfect on the blueprints. The sales were record-breaking. Celebrities and international moguls fought over the units. But as the building approached its full height, the sensors began to pick up a terrifying trend. The building wasn't just settling, it was leaning. And it wasn't leaning toward the street, it was leaning toward the water. The problem with a 3-inch per year tilt is that it isn't linear, it's accelerating. As the building leans, the center of gravity shifts. This puts more pressure on the piles on the low side of the building. That increased pressure causes the limestone underneath those specific piles to compress or even crush at a microscopic level. As the ground gives way, the building leans more. As it leans more, the pressure increases again. It is a vicious cycle of physics that is incredibly difficult to break once it starts. Imagine trying to catch a falling tree with your bare hands. Now imagine that tree weighs 400 million pounds and is made of glass and reinforced concrete. Why can't they just fix it? In other cities like San Francisco, they have tried to fix leaning towers by adding new piles down to the bedrock. But in Miami, there is no bedrock in the traditional sense. You can go down 1,000 feet, and you are still hitting porous, waterlogged material. To truly stabilize a building of this weight that has already started a significant tilt, you would have to essentially rebuild the entire foundation while the building is standing. You would have to freeze the ground with liquid nitrogen or pump millions of gallons of high-tech grout into the limestone voids. But here is the problem with grout. If you pump it in at high pressure, you risk blowing out the limestone crust and causing a sinkhole that would swallow the building and the neighbors. It is a surgical procedure where the patient's bones are made of crackers. The interior of the building is where the reality of the tilt becomes undeniable. Luxury skyscrapers are designed with incredibly tight tolerances. The elevator cables, for instance, hang like huge pendulums. If the building is 3 inches out of alignment this year and 6 inches the next, those cables will eventually start hitting the sides of the elevator shafts. The doors won't line up with the floors. The high-speed elevators, which are a selling point for a $900 million tower, would have to be slowed down or shut off entirely for safety. Then there is the plumbing. Water doesn't like to flow uphill. Every drain and sewer pipe in that building was designed with a specific fall to let gravity do the work. A 3-inch tilt per year means that within half a decade, the toilets on the high side of the building might stop draining, while the low side gets everything backed up. It is a functional collapse that happens long before a structural collapse. The owners are in a state of absolute shock. Imagine spending $20 million on a home that is technically moving. The legal battles have already begun, but who do you sue? The architects followed the codes. The engineers did the math based on the geological surveys they were given. The city inspectors signed off on the plans. In the world of failing megaprojects, everyone points a finger at someone else until the money runs out. The reality is that we are likely seeing the first major victim of climatic engineering failure. As sea levels rise and the water table in Miami fluctuates, the limestone sponge is becoming even more unstable. The ground today is not the ground it was 20 years ago. This brings us to the most chilling part of the story, the point of no return. There is a specific angle of tilt where a building's internal skeleton can no longer compensate for the stress. Skyscrapers are designed to be flexible, to sway in the wind, but they are not designed to be permanently bent. Every beam and every joint on the high side of the tilt is being pulled apart, while every joint on the low side is being crushed. Eventually, the steel inside the concrete will begin to yield. Once that happens, the building's structural integrity is gone. It doesn't mean it will tip over tomorrow, but it means it is no longer a safe structure to occupy. It becomes a $900 million tomb for dreams and investment capital. Why can't we just demolish it and start over? Demolishing a skyscraper in a dense, coastal environment like Miami is an absolute nightmare. You can't use explosives. The vibration would likely trigger more ground movement and damage the surrounding multi-million-dollar towers. You would have to take it apart piece by piece, from the top down, using cranes that are themselves anchored into that same unstable ground. The cost of a controlled deconstruction could be hundreds of millions of dollars. When you add that to the $900 million already spent on construction, you are looking at $1 billion loss that practically nobody is willing to pay for. Insurance companies have teams of lawyers specifically designed to avoid paying out for predictable geological movements. This tower is becoming a symbol of the Great Miami Reset. For years, the city has ignored the warnings of geologists who said the limestone could not support these massive vertical cities. We have treated the ground like it was solid granite, when in reality, it was always a moving, living system. The 3-inch tilt per year is the Earth's way of saying that the limit has been reached. It is a physical manifestation of human arrogance. We wanted to touch the clouds, but we forgot to check the mud. What makes this case especially fascinating for those of us who follow mega-project failures is the secrecy. Unlike the Millennium Tower in San Francisco, which became a public scandal almost immediately, the Miami Tower is wrapped in non-disclosure agreements. The owners don't want the world to know their investment is sinking because they still hope they can sell it to some unsuspecting buyer before the tilt becomes too obvious. The management companies talk about routine maintenance while workers are frantically trying to patch cracks that reappear every week. It is a conspiracy of silence fueled by the desperate hope that a miracle engineering solution will appear. But according to the latest reports from independent structural analysts, there is no miracle on the horizon. The options are dwindling. They could try underpinning, which involves digging under the foundation to add more support, but the high water table in Miami makes that almost impossible. They would have to create a cofferdam, effectively a giant underground bathtub, just to keep the Atlantic Ocean out while they work. The cost of that alone would be astronomical. Another option is a mass damper adjustment, where they move a massive concrete weight at the top of the building to try and balance the lean, but that doesn't solve the problem of the ground giving way. It just masks the symptom while the disease continues to spread. As we look at the Miami skyline, we have to wonder how many other luxury towers are secretly leaning. If one $900 million project can fail this spectacularly, what does it mean for the dozens of other towers currently under construction? We are watching a real-time experiment in whether or not a major American city can continue to grow vertically on a foundation of water and sponge. If this tower cannot be saved, it could trigger a massive exodus of capital from the Miami real estate market. Who wants to buy a penthouse in a city where the buildings have an expiration date? The 3 inches a year figure is particularly haunting because of the speed. In 20 years, that's 5 feet of movement. By that point, the building would be leaning more than the Leaning Tower of Pisa. But while Pisa is a worldwide tourist attraction, a leaning modern skyscraper is just a hazard. The glass panels would pop out and fall like giant guillotines. The structural fireproofing would crack, leaving the steel vulnerable. The very essence of what makes a skyscraper work, its verticality, would be gone. I want you to think about the people who worked on this. The architects who spent years obsessed over the curve of the glass and the flow of the lobby. The workers who braved the Florida heat to pour the concrete. All of that labor, all of that human energy, is now being neutralized by the slow, silent movement of the Earth. In the battle between humanity's ambition and the planet's geology, geology is currently winning in a blowout. It is a reminder that we are guests on this planet, and the ground we walk on isn't as permanent as we like to think. Inside the tower, the silent signs of the fail are everywhere. In the mechanical rooms, you might see shims and spacers placed under heavy equipment to keep them level. In the stairwells, you might see telltale glass strips placed across cracks. If the strip breaks, the engineers know the crack is widening. These are the tools of a trade that is trying to manage a disaster that has already happened. It is the architectural equivalent of putting a Band-Aid on a broken limb. The unsavable nature of the building comes down to the math of the return on investment. If it costs $400 million to potentially fix a building worth $900 million, and the fix isn't guaranteed to work, no bank is going to lend that money. The building becomes a stranded asset. It sits there partially occupied, while the owners wait for the legal system to tell them who to blame. It is a vertical ghost town in the making. As we analyze this from a project management perspective, the failure began in the site selection and risk assessment phase. There was a desire to build in a specific prestigious location, and that desire blinded the stakeholders to the reality of the soil. They saw what they wanted to see. They saw a profitable tower. They didn't see the porous limestone. They didn't see the rising water table. They didn't see the 3-inch tilt that would eventually define the project. It is a case study in confirmation bias on a billion-dollar scale. And so the Miami Tower stands today, reflecting the beautiful Florida sun, looking for all the world like a success story. But deep underground, the piles are groaning, the limestone is crushing, and the building is inching its way closer to an unavoidable fate. It is a story of wealth, water, and the cold, hard laws of physics. It tells us that in the world of mega projects, the most expensive thing you can build is a building that ignores the earth it stands on. For the viewers of this channel who are fascinated by these engineering shipwrecks, the Miami Tower is a perfect storm. It combines the complexity of modern architecture with the unpredictability of local geology. It represents a turning point in how we think about coastal development. The Leaning Tower of Miami isn't just a building. It's a warning. It's a message written in glass and concrete, telling us that the era of building whatever we want, wherever we want, is coming to a close. What happens when the tilt reaches 4 inches a year? Or 5? At some point, the city will have no choice but to evacuate the building for public safety. When that day comes, the secret will be out, and the $900 million asset will officially become a $900 million liability. The skyline of Miami will have a gap where a giant once stood, or worse, a skeletal ruin that serves as a permanent reminder of our failure to respect the ground. The 3-inch tilt is a heartbeat. It's a rhythmic annual reminder that the building is alive in all the wrong ways. It's moving, it's breathing, it's failing. And as much as we want to believe that we can engineer our way out of any problem, the Miami Tower shows us that some problems are simply too big to fix. Some mistakes are permanent, and some billion-dollar projects are destined to become nothing more than a cautionary tale for the next generation of builders. If you are ever walking along the Miami beach and you look up at these gleaming towers, try to imagine the forces at play beneath your feet. Imagine the pressure, the water, and the fragile limestone holding it all up. The Miami Tower is just one example, but it's an example that should make us all look a little more closely at the ground we stand on. Because in a city built on water and stone, the only thing more certain than the tide is the fact that eventually, everything returns to the earth. This $900 million tower is a masterpiece of design that forgot the most basic rule of nature. You need a solid foundation. And without it, you aren't building a home, you are just renting space from a planet that is ready to take it back. Keep watching the horizon. Keep asking the difficult questions, and remember that in the world of mega projects, the most impressive thing isn't how high you can go, but how long you can stay there. The Miami Tower's time is running out, 3 inches at a time, and the world is watching to see how this billion-dollar drama ends. It is a story with no heroes, only survivors, and the inevitable gravity that brings us all back to level, whether we like it or not. As the sun sets over the Atlantic, the tower casts a long, slightly crooked shadow. It's a shadow that will only get longer and more distorted as the years go by. It is the shadow of a failing giant, a monument to the fact that money can buy almost anything, but it can't buy a solid foundation where one doesn't exist. This is the truth of the Miami Tower, a building that can't be stopped, can't be saved, and will eventually be remembered as the greatest lesson the city never wanted to learn. Stay tuned as we keep track of this sinking giant and more projects like it around the world. The world of engineering is full of wonders, but it's the mistakes that teach us the most, and this $900 million mistake is one for the history books.